Good afternoon, everyone. Today, the last lecture of Module 2. Our last lecture topic is the wood. We talk about the timber material today. The wood has been appealing architectural material for centuries. Because it has warm aesthetic, it can using for the structural component as well as using for the exterior cladding. And it used as the interior design and also exterior design. So today, I'll cover the basic materiality and the basic timber construction assembly issues. So I bring the first image here, designed by the Ginny Gang, and it is in the Chicago. So you can see this is a very well to expressing about the timber, the product. The timber can be structured, it can support by itself, and it is also very flexible material. So it means it is easy to making out this bending structure. Okay, so now we just talk about what is about the timber, the characteristic. Okay, and then we understanding about what is about the basic materiality of the timber. The architecture timber product are certified from FSC. The FSC, I just kind of announced it here, the Forest Stewardship Council. Okay, it is an international non-profit organization. The FSC made standard setting on the forest product. It is along with certifying and labeling them as eco-friendly. Okay, so when you're just getting the timber product for your project, you usually can see this FSC label on your product. Okay, it is more representing the natural material and eco-friendly material. So let's talk about the timber, the characteristic. The wood have high strength and the flexible materials. It is very good material to support building structure itself. And just kind of interesting about this case study project here. It is 9 Bridge Country Club building designed by the Shigeru Ban. So when you see this building, you can see this umbrella structure timber, and then this umbrella, the weaved structure, the timber structure support the ceiling system. So when you just kind of find out the timber can works as the column, which is the structure column, it also works as a structure to support the ceiling. And also you can see the last of athletic way to expressing about the timber product. It is easy to the bending to making out these types of the organic form. So because about the flexibility. So as we talk about the timber has the flexibility. You see the project here. It is a temporary structure built at the PS1 New York City. It is called bamboo canopy, designed by an architect. The canopy is constructed of 1,100 fresh cut green bamboo, harvested in Georgia. This example is very well to representing timber has the flexibility. It is available in making this bending shape easily. Also, the timber is considered as a renewable material. So we are using the timber as needed, and then it need a plantation after consuming tree, the way for the growing up for the next harvesting. So simply understanding about this one, we have a plantation of your timber, and then it growing, it's cultivation, and after cultivating the tree and harvesting it, and then making out the timber product, you shipping to the construction site basically from this harvesting timber. And we using this timber for your project, and then you have a lot of waste material from your project, and even you can reuse this waste material to making the wood chip fuel. So means this is more about the circular this cycle. So that's why timber is keep growing when you're harvesting from the plantation, and also when you're using the timber product, it can be going back to the nature because it's made by the wood chip fuel after the waste of the materials. So it is also simple, the fabrication comparing to the other architectural material. It is very easy to make out the foam, easy to fabricate in the foam. Because about the timber is easy workability and it can transform any shape and form from the different the tool to use for this fabrication. So using these types about the fabrication, and nowadays you can also using the digital fabrication tool like a CNC milling machine. So it means using these types about the digital tool to create the lots of a different pattern and lots of a different the form you can create. So I using the CNC milling machine. So I just can simply the stacking the several timber layer and then using the CNC milling machine to shaping the some form to making out this interesting the grain texture. So it means the developing this digital tool, you can the making the lots of a different fabrication style, and you can just making the lots of a different the product style from your the design the requirement. So now we talk about the fragrances. The wood has the characterized fragrance depending on the tree species. Each timber has the unique the smell, which is the fragrance. So in making the very unique feature, I mean unique in making the unique atmosphere of the space from the fragrance. So that's why timber compared to other material, it has the unique material because it making out the smell. It also making the warm material of the space. The timber is also available the lots of different color option. So you can see the different color option depending on your design preference. You can choosing your preferred tone for your interior or exterior the finish material. Even you can consider about the various option to your space. This is a wood floor option. So we can see the different colored option. Also it has the lots of different finish texture. It is available smooth, rough, glossy, or the matte finish. Depending on your design preference, you can choose in the proper texture and you can choose in the proper tone and color for your project. And next one, the timber has the unique pattern. And then it has the grain, right? The grain making the lots of interesting, the interior and exterior, the overall looking, right? Also you have to know about the timber has the different texture according as the faces. So you can see the three different faces from the timber product. So you can see the face and edge and the end grain. Okay, the face grain, you usually can see the wood, the grain pattern and texture, right? So face grain, you can just find that the timber wood grain, you can see, and then edge grain, so you can see the edge grain here. So edge grain, you can usually find that the vertical, the texture and pattern, and end grain, usually you can find that the circular, the grain you can find out. So means depending on your desiring the texture and pattern, you can using the prepare the facing from your timber product. The wood grain is determined by the cutting orientation. Okay, so remember about these three different the cutting orientation. I just ask you to memorize these three different the cutting method: the plane zone, and the quarter zone, and the lift zone. Depending on the cutting method, it can have the different the pattern and texture. The first we can see the plane zone. You can see the plane zone. The plane zone is the cut timber the by parallel orientation of annual link. So see the annual link here. So this is a cutting that is parallel to the annual link. And when you're just cutting out this plane zone, you can see that the timber, the wood grain pattern you can find out. And then the quarter zone and lift zone is pretty similar. The quarter zone and lift zone, first they have to be cutting the quarter, and then this both quarter zone and lift zone is same. They just first cutting the quarter, but has a little bit different cutting after cutting by the quarter of your timber log. The cornerstone here, you see the cornerstone and liftstone. The cornerstone, so this is simply cutting the 45 degree after cutting the corner of the timber log. So you can see the 45 degree angle. Okay, and then when you're cutting out these 45 degree angle from the cornerstone, you can see these types of the texture. Okay, but what about the liftstone? Just cutting the corner first, and then just cutting everything perpendicularly to the annual ring. Okay, in this case, this can mostly find the more vertical the pattern. Okay, so cornerstone is between the cornerstone pattern is between the plain stone and liftstone. So that's why you can still see the annual ring. Okay, and you can also see that this vertical, the texture and pattern. Okay, so you can simply understanding about the cornerstone and the plain stone. The plain stone is more about the annual ring you can find out, and the corner and liftstone you can mostly find that this vertical, the pattern you can find out. Okay, so I just kind of summarize one more time to understanding better about the plain stone and cornerstone and liftstone. It is different the cutting method depending on the orientation. The plain stone, it is simply parallel cutting from the annual ring, and cornerstone and liftstone is very similar. It's cut the corner, and then the cornerstone, it is cutting 45 degree toward annual ring, and then liftstone is cutting the 90 degree angle toward annual ring. So when you see the cornerstone and liftstone, it is usually can find out the vertical, the pattern. However, plain stone, you can mostly find out this circular annual ring, which is the wood grain pattern you can find out. Okay, so I just kind of asking about these difference, these three different cutting method in the quiz. So please understanding about the concept. Okay, and then so lumber grade, depending on the location to use, it has a little bit different the strengths. For the tension is the pulling process. It's kind of like a pulling process. You can see the tension is pulling process here, and like here and here. So you can also see the wood grain. This is a wood grain pattern. So parallel to the grain, which is a parallel to the grain, is 100 times stronger than the perpendicular to the grain. So means the parallel to the grain in a tension, it is 100 times stronger than the perpendicular to the grain. Okay. What about the compression? Compression is like a push process. In this case, this parallel to the grain is 4 times stronger than the perpendicular to the grain. Okay. The tension and compression, the parallel to the grain is much stronger than the perpendicular to the grain. What about the shear? The shear is the sliding failure, means the top part is kind of pushing this side and the bottom part pushing this side. It is kind of different, the pushing side to making the sliding failure. Okay, so in this case you can see the pushing each other, and then this is a pushing the top and bottom different the direction. In this case, the parallel to the grain, which is the parallel to the grain, is substantially less stronger than the perpendicular to the grain. So just understanding about the compression and tension, the parallel to the grain, which is a parallel to the grain, is much stronger than a perpendicular to the grain. However, for the shear, it is the parallel to the grain is little less stronger than perpendicular to the grain. So it means to using your structure for the timber, you have to know about your orientation to using for your timber product. So to support the proper the structure weight. So it means you have to be using the parallel to the grain. This is much stronger than perpendicular to the grain. That's why you have to be choosing the proper orientation to using for the timber for structure member. Okay, so the understanding about the parallel to the grain in a tension and compression is much stronger than the perpendicular to the grain, but shear is pretty similar, but still parallel to the grain is substantially little less than perpendicular to the grain. Okay, so you have understanding about the grain always start like that. It means the parallel to the grain is about this. Okay, and the perpendicular to the grain is like that. Okay, so please understanding about this concept for your structure, the member to using for your design later. Okay. So now we talk about the veneer. What is about the veneer timber? The veneer wood is the layer of wood. You see that it's very thin layer of the wood. So it is made by the sliced or peeled from the lumber. It covers any surface. So it means, mostly kind of pretty similar texture as the solid wood material. However, the veneer product is much cheaper than the solid wood material because it is only need the very thin layer of the timber, and then this is simply the attach any types of the composite material. So it means instead of using the actual thickness of the solid wood, you only require the very thin layer. So from this reason, to save your construction money, you might consider using this veneer wood product. But now we can see how do we make this thin veneer product. It has the two options. The first one, the rotary field, and next one is sliced. So what is about the rotary field? In the rotary filling, the log is filled by the blade and it's work around the log toward the center to create wood veneer. So it means you can see the blade here, this cutting toward the center, which is the core of the timber log, and then it's just making the more continuous the pattern made by the rotary filling method. What about the sliced? You're just making out the wood block, and then as you can see the blade, just cutting the one single direction to making out the veneer, the pattern. So from this reason, it has the more repeated pattern you can find out. So comparing to the rotary filling and the sliced, the veneer fabrication, the rotary filling has the more continuous the pattern you can find out because it just kind of making out the more continuous the outer ring from the log. However, sliced, it made by the log block and then just cutting the layer by layer. So that's why it can have a more repetitive pattern. So we can create lots of different texture pattern depending on the different grain combination method. Let's review 4 different types. You can make in the 4 different pattern texture from the veneer timber to making the unique pattern. The first one, the book matching, and second, the slip matching, and third, the plank matching, and fourth, random matching. The book matching type, each piece have a mirrored image. You see this pattern and this pattern is simply the mirror together. What is about the slip matching? The slip matching, it produces the staggered image across the face, having the same face over and over to making out the pattern. The plank matching, it deliberate the mismatching manner to achieve natural lumber. If you want having the more continuous the pattern, you might consider to use the plank matching. So it's simply a mix matching manner to making this continuous pattern. Then random matching. The random matching here, it doesn't have a consideration given to matching for the color or grain. It's just making them randomly place each other. Okay, so it means to producing about the veneer pattern, you can consider about these 4 different methods to making out the veneer pattern. So now it is important to know about the 2 different wood type, the softwood and hardwood. So you just have to be understanding about what is difference between the softwood and hardwood. The softwood you can mostly find out from the conifer species, which is the fir, hemlock, spruce, and pine. It is usually less expensive than the hardwood. Okay, And then it is mostly using for the building component and the structure, which is the window and door. It is limited finish uses because it has the BG and ruler, the grain, the pattern. So this is not suitable to using the finish uses. However, it is great to using the building component and building structure. But what about the hardwood? Hardwood you mostly can find out from oak, cherry, ash, the walnut, the birch, and poplar. It is more expensive typically. And then if finish use is typically here. Okay, so just understanding what is difference between the softwood and hardwood. The softwood is from the conifer, that's why it is less expensive than hardwood. And then the hardwood is beautiful, the finish looking. That's why it is usually using for the finish use. Okay, but the softwood is stronger. That's why you can using for the building component and the building structure. But it is not great the finish looking. That's why it is limited finish uses. Okay, but the hardwood you can see there is much the loose between the cell, which is the stem cell. That's why it is very weak comparing to the softwood. So from this region is limited structure uses. So hardwood is mostly you can just using for the finish use. It's not using for the building component and then the structure uses. Okay. So now we talk about the lumber grade. When you purchase the timber product, you can see these lumber grade for every the timber product. So lumber grade has the 4 different category. The SER, STR is a selected structure, number 1, number 2, and number 3. The SER, STR is the best quality timber, and then number 3 is the worst timber quality. So you can see the number 3, you can see the loss of a defection. You can see the nut and then loss of a defection around. So it means number 3 is usually much weaker structure than the SER, STR level because of a level loss of defection. Okay, so depending on your structure uses and then the support, the weight, you might consider about the proper the lumber grade for your product. Okay, so just understanding about what is the 4 different number the grade, which is the SER, STR to the number 3. But you can see when you purchase the product, you can find out these kind of label. How we can read about this label. So I just giving this example here. So first one, you can find out your lumber grade. It say about the number 2, which is this number 2 grade to using for this timber product. But it is say the SER, STR, which is the best quality timber in used. Okay. Next one, you can find out the species, which is they use the hemp fir per this product. Okay, it's made by the hemp fir for this is the representing the species. Now we can also find out SGRN and S dry here. What is about the SGRN? The GRN is green. Okay. But what is difference between S green and S dry? S green, it is the more than 19% moisture content. So think about it. If your timber contained water or moisture, it is easy to shrink and warp, right? So that's why when you want to using the S green grade timber for your structure, you have to be dried first. Okay. However, when you use the S dry, it is under 19% water content in the timber product. So means it's much less shrink and warp because it doesn't have any water compared to the S green the grade. So it means when you see the S dry for your timber product, you can use this timber right away for your structure member. Okay. As I discussed, the timber has the loss of a defection. Okay. You don't need to be worried about these all the different terminology. but you have to be understanding about the timber product. Timber is breathable and live material. So it means it can be attacked from the termite, or it can be easy to the warp or knot or crook, because about the timber is kind of breathable. And then if it has to contain the water moisture, it is usually easy to bend. So that's why when you're using the timber, you have to be choosing your timber product very well. You have to be checking these timber, the grade label, to choosing your timber product properly for your design. Okay. So now we talk about the Gulam, which is the laminated timber. What is about the Gulam? The Gulam is also called as the laminated timber. It is structural engineered wood product. It comprises the lumber layer, the bonded together for the durable and moisture resistant structure adhesive. Okay, so you can see that you can using the lots of different layer and then like a sandwiching together with the structure adhesive. So it means when you simply combining the several layer of the timber, you can make a much stronger timber comparing to the one solid timber, because using the structure adhesive, it put together very well, and then also it's stronger the moisture protection comparing to the normal solid timber. Okay, so now we can just kind of watch about the how we can the making out this Gulam, the timber. But also we have to be understanding about how we can the bend this Gulam timber, because about the Gulam is easy to the bending for the structure. So when you just kind of find out these types of the image, and then how we can the bend this curved structure, the Gulam is available to making this curved structure. Okay, but how we can make the bent wood? The wood should be steamed 1 hour per each inch of the thickness. If the Gulam has 1 inch, you have to be steamed the water for the 1 hour. But if you have a 3-inch thickness, you need 3 hours the moisture steamed to making out the bent structure. Okay. So using this Gulam product, you can see this curved the structure. So you can just using this curved Gulam for making out these types about the structure. Okay. So next we talk about the cross laminated timber, which is a CLT. So this is a pretty similar as the Gulam, but you can see what is difference between the CLT and Gulam. The Gulam is stacking the one direction, right? Simply stacking each layer. However, the cross laminated timber, which is the stacking the different orientation. One is kind of parallel to the grain, and another one is perpendicular to the grain, and then the parallel to the grain. So it means this is having a different orientation to stacking each layer together. So it means, so when you're combining the different orientation of the timber layer, it making it much stronger than typical Gulam. Also, it is much dimensionally stability. So means the CLT is stronger than the Gulam. It is also the more accuracy for the dimension. Okay, so from this reason, nowadays we using this timber product for the high-rise the building. the CLT is available to making the high-rise building to using the timber product. Okay. So we just kind of watched the one more video introducing about the CLT and how we're using the CLT in our industry. I think you better to understanding about the future, the timber, the structure method. Okay, you just kind of using the CLT. Even you can just build up to 30, 40 story high the building. Okay, let's watch the video and then we talk about the next topic.
Cross-laminated timber, or CLT, is an engineered timber product that is threatening to upset the dominance of the big two structural materials, concrete and steel. Initially driven by the material's sustainable credentials, cross-laminated timber buildings are gaining traction, as they can be quicker, cheaper, cleaner, and quieter to build than traditional structures. Over the past 5 years, the use of CLT in construction has risen dramatically. The material is now being used to construct impressive and sustainable homes, offices, schools, and towers. Often referred to as super plywood, the material is constructed in a controlled factory environment from sustainably sourced timber. CLT is manufactured from spruce, although Scots pine, larch, and Douglas fir can also be used. Once at the factory, the timber is planed and then kiln dried to reduce moisture content. The conditioned timber is then stacked into layers, known as lamellas, on top of one another. Each layer is placed at a 90-degree angle to the one beneath. These layers are then glued using a non-toxic adhesive and hydraulically pressed together to create the high-strength structural panels. Individual panels can in theory be any size. However, their width is limited by the size of the manufacturing machinery, which is usually around 11 feet or 3.5 meters wide. The length of the panel is only dictated by how it will be transported to site. While 45 feet or 13.5 meter lengths are typical for practical purposes, panels of up to 75 feet or 22 meters have been produced. Using state-of-the-art, computer numerically controlled or CNC joinery machines, almost any shape of panel can be produced, meaning that door and window openings can be pre-cut in the factory. These off-site manufactured panels are then ready to be delivered to site. Fabrication is currently limited to only a handful of factories in mainly Alpine countries, such as Stora Enso's in Austria. While this may require the panels to be transported to site by road, the embodied energy added to the project is far outweighed by the carbon savings. Proponents of CLT claim that producing timber building components consumes only 50% of the energy required to produce concrete, and a mere 1% of that needed to produce steel. The prefabricated panels can be delivered to site as they're needed, making this construction method ideal for schemes with limited on-site storage capacity. They are then lifted into place using pre-installed lifting straps and rapidly assembled, greatly reducing construction time and therefore cost. As the timber used is kiln dried, CLT should not shrink or warp when on site. However, like most timber elements, CLT must be placed above the damp-proof level and will need protection when used on the external facade. CLT construction can also reduce the self-weight of a structure compared to concrete, potentially reducing groundwork costs. The construction process is also cleaner than traditional methods, with greatly reduced levels of dust. It is also quieter, a distinct advantage for projects built in urban areas. While there are numerous benefits to CLT, some people are fearful of living or working in timber buildings. Some believe these structures have an inherent fire risk, particularly when rising to 10, 20 or 30 stories tall. Unlike unprotected steel, CLT can remain structurally stable when subjected to high temperatures. When exposed to fire, the outer layer timber chars and forms a layer around the structural core, which can retain its load-bearing capacity. CLT's inherent fire resistance allows it to comply with fire resistance classes, withstanding blazes for between 30 and 120 minutes, depending on its engineering and formation. CLT uptake and use was initially driven by the material's sustainable credentials. However, in recent times, the resurgent construction market that is placing pressure on traditional materials, along with increased awareness, has bolstered adoption. While early CLT buildings were predominantly small, low-rise structures, the material is increasingly being considered for taller schemes. Since architect Walt Thistleton built the first timber skyscraper, or ply scraper, in 2009, tall timber buildings have been planned around the world. In the past 5 years, towers of 30 metres, constructed from CLT, have risen in Australia, America and Europe.
So now we talk about the basic framing. Okay, so how we using these timber framing to making out the wall or making out the slab. So we can talk about the basic wood framing in wood construction building. When I worked in San Francisco, so working on this project, it is the type 5, the building construction. You remember what is type 5, which is the timber structure. So and then it just making out the timber structure for the structure, and then we using the wall framing using the timber product. You see this is a construction image. You see everything made by the timber framing. You see the wall and ceiling and then floor, right? So now we talk about how we can designing the wall framing using the timber. So now we just understanding about some terminology and some the rule to making out the wall framing by wood. This is a basic wood framing wall diagram. So usually between the vertical stud, timber to timber, it is usually 16-inch center to center. Okay, this is an atypical number. So when you're designing about the timber framing, and then the vertical stud to the vertical stud, this and this one, you need to be provide the 16-inch distance. Also, you can say that when you're just designing about the timber framing, the bottom layer always kind of a single layer, but top layer always having this double layer here. So this is what we can call double top plate. You have to know the top plate always having the double layer, the bottom plate always having the single layer. Okay, and the bottom one is the bottom plate. And then, so when you're just kind of designing about the opening to support this opening better, and then you have to provide the vertical framing. It is called as the king stud. It is for the window and door, and then making at the top of window and door to supporting these top pieces, it is called jack stud. Okay, the bigger one is king, and then the medium sized one is jack stud. And then top part, the top of your opening, like top of your window, top of your door, it is called as the header. Okay, which is header. The bottom of the opening, it is called as the saddle. Okay, then to support this opening from the top and bottom, for the door is only from the top, it is called as the cripple stud. Okay, this cripple stud support the opening space top and bottom. And then end of your wall, your wall is about to up to from here to here, and end of the wall for the framing, it is called as the end stud. Okay, so just kind of understanding about the concept. You don't need to memorize everything, but eventually you have to know the old terminology to communicate with the contractor. But for now, you just kind of understanding about the concept and to know about the terminology, and then you just kind of keep looking at this terminology to use to understanding about it. Next one, to connect the frame to flame, which is the bottom plate or top plate, to connect to the vertical stud, you can consider to using these three different methods. The end nailing is only with one pin joint, but if you want to having the stronger joint, you can consider the toe nailing. And then when you want to making out the face to face the timber connection, you can consider to use the face nailing. Okay, Now we talk about the corner condition. So this is all about the wall itself. But how about the corner design? So when you have a wall here, and then when you have another wall here, but how you can designing about this corner condition? Okay, so this corner condition, the conventional corner condition, you have a end joist here, and you have another end joist. But to protect this corner condition, you should adding this additional stud to protect this corner joint, because having the joint here, so this joint is very weak. That's why you have to be adding the additional stud to protect the joint. But what is this problem? Because when you see this issue, I can erase this one. So you can find out that when you're having the end stud, and then stud for the joint, you're just having the blank space here. So it is difficult to adding the insulation. So means it is hard to adding the insulation. This corner condition is easy to losing the loss of heat energy from the inside to the outside, because it doesn't have any protect from the insulation. But that's why currently we more to consider about the California corner. Okay, this California corner is very similar as the conventional corner. The California corner has the two end stud here, the two end stud. But instead of doing this stud orientation like this, it is keep protecting this corner condition. Also, you can make the more continuous the insulation up to this end joist. It means it can be better the protection, which is a thermal protection comparing to the conventional corner. So to designing about your timber structure, so you can consider to using the wall assembly and the floor assembly and the roof assembly. So today I'm more to introducing about the floor and wall assembly. So today just talk about the two different framing method. The first one is platform framing, and second one is balloon framing. It is very important to know about the concept. You should know about what is difference between these two framing system. So now we talk about the two framing method is platform framing and balloon framing. It is introducing about how the timber floor assemblage can connect to the wall assemblage. Okay, so there are two different options: the platform assembly and the balloon assembly. So platform assembly is sitting on the bottom plate. You can see that this is the bottom plate, and then the joist, which is for the structure for the slab, then sitting over the bottom plate here. Okay, so this name comes from each floor level being framed as the separate platform. It means for the platform assembly, it is built the floor by the floor. Okay, it just finished the first level, the floor framing from the wall and the floor, and then it start to construct the second level. Okay, so but the balloon assembly, it is having the more continuous the wall from the bottom to the top. Okay, the balloon framing sit on the sill plate and nailed together between the stud and the joist. You see here what is the difference between here and here. The balloon framing, the joist for the slab, they were nailing down to this vertical frame, which is a vertical stud. However, for the platform, this joist nailing down to the ceiling plate, and then it has the end joist here. Okay, you can see the end joist, but it doesn't have an end joist. It's open here. Okay, because the balloon framing is continuous framing from the ground level to the top, but platform framing is built sequentially, which is the level to level. So we can simply understanding about the difference between the platform framing, as I talk about, it is built the floor to floor. So it means it is usually much cheaper construction cost compared to the balloon assembly, and it's also much faster the construction time compared to the balloon assembly. But what is about the benefit for the balloon assembly? It means you see the platform assembly, every floor have this end joist. However, balloon assembly, it doesn't have any end joist here. It means it is available to making the taller and higher ceiling, because about when you just design the platform assembly, you only can designing about the opening from the here to here, like here to here. But for the balloon assembly, you can just making the higher the opening comparing to the platform assembly. However, mostly timber product, we using the platform assembly. It is much the common solution for your framing design. Then you are better to understanding from this diagram. So you can see the first image and second image. You imaging about what is about the platform framing and then what is about the balloon framing. So you can see you remember of the platform framing, the finish the level by level consequently. So means they just finish the first level with the frame and then they start the second frame with the framing. Also, what is biggest difference between the balloon and platform? They have end joist for the platform framing. You see the end joist here and here, and also the vertical stud starting over this end joist. Okay, so means you can see the balloon framing. It is having the more continuous the vertical stud, and then the joist simply nailing down to this vertical stud. Okay, so it means you can still having the vertical continuous the stud, and you can having the connection, this horizontal connection to this vertical stud. So you need to be understanding what is difference between the platform and the balloon framing. So platform first, it is built the floor to floor. So it means it is making the frame by the floor to floor. The balloon is having the more continuous framing from the bottom to top. So it means the platform framing has the end joist, but the balloon framing doesn't have any end joist. The joist, which is for the floor, is simply the nailing down the vertical stud for the balloon, but the platform framing, this vertical stud sitting over this end joist and then the all structure frame. Okay, so you can better to understanding on the section here. So you just kind of imaging about what is about the difference between these two. You having the end joist here, it doesn't have any end joist. If you have end joist, it is called as platform framing. But if you don't have any end joist, and it is called as the balloon framing. Okay, so you can see the end joist here and here. This is construct the framing, the floor to floor. However, the balloon framing, it doesn't have an end joist. It means it has the continuous the vertical stud from the bottom to top, and then the horizontal, which is the slab based joist structure, simply the nailing down to this vertical stud. Okay, please understanding about these two concepts. What is difference between the platform and balloon, and then what is more common the framing type for our industry, and then what is about the benefit for the balloon. You remember the benefit for the balloon, you can make in the higher opening comparing to the platform framing because it doesn't have any end joist. Now we talk about how you deciding about your timber size. Okay, so it is about your lab assignment. You don't too much worry about how you can using these information in your final exam or the module quiz, because we talk about this concept again on the next semester. Okay, so but you have to be understanding about the concept to apply this information for your lab assignment, and also it is very important in the practical field because you have to be know about the initial concept to deciding about the timber the product. Okay, so now you can deciding about the wood stud wall and how you can deciding about the height basically from the timber size. Okay, so first one, your building only have a single story with a roof. In this case, you can use the 2x4 or 2x6, but in this case, you can use the 24-inch between the space between the vertical stud, okay? But when your building has the one floor and the roof, which is the two-story building, it means the bottom place, the support, the second floor, and the roof. In this case, you still consider about using the 2x4 and 2x6. So what is about the 2x4? It is about the lumber size. 2x4, which is the actual size of the 2x4, is at 1.5 inch by 3.5 inch. Okay, and the 2x6, which is 1.5 inch, and then this is 5.5 inch. This is the actual size about the timber. It means 2x6 is bigger than 2x4. It means 2x6 timber is stronger than 2x4. Okay, so it means you can say if you have in the support, the one floor and the roof, when you use a 2x4, you can just make in the 16-inch distance between the vertical stud. However, when you wanna make in the 2x6, it's bigger stud, it means stronger one. You can make in the more distance compared to the 2x4, right? Because about the weaker one, you have to be more dense to support to the weight. But if you have a stronger one, you can make more distance between the timber, okay? And then if your product having some supporting the two floor, which is here, two floor, and the roof, in this case, you have to be using the 2x6, but it has to have in the 16-inch distance, okay? But if your building has the 3 floors supporting 1, 2, 3, and roof, in this case, you have to be using the 2x8. You have to be using the 16-inch distance between the stud. 2x8 is bigger than 2x6. It means it is stronger than 2x6 product. Okay. So now we talk about how much tall you can reach depending on your timber size. So for example, when you want to use the 2x4, your building can reach up to the 14 feet. Okay, so means using the 2x4 product, you can making out the 14 feet tall wall, right? But when you want to use the 2x6, you can reach up to around 22 feet. But when you want to use the 2x8, you can reach up to around 30 feet. So means depending on the height of the building and height of the floor to floor space, you can deciding about the size about your timber for the framing. Okay. So next we talk about the span. What is about the span? The span is the distance between the structure member to structure member. In this case, this is a wood floor joist, which is what is the span from here. The span is from here to here. So this is the structure slab, and then it is your structure beam, and this is another structure beam. Span means from here to here. It is distance between the two structure member. It is called as the span. Okay, but you can also decide this span distance depending on the timber size, which is a joist size, this is a joist size. If you're using the joist 2x6 with a normal wood, your timber span can reach up to around 10 feet. But if you have a stronger wood, your timber span reach up to around maybe more than the 10 feet here, right? So if you have the bigger, the thicker joist, which is a 2x12, which is almost twice bigger than 2x6. In this case, you can reach up to around maybe 16 to 17 feet when you're using the normal wood. But when you want to use the stronger wood, your timber span can reach up to around 22 feet. So means you can simply understanding about it when you're using this joist using the 2x12. So 2x12 means you're having this joist here, right? Which is here is 12 is about 2, and then here is about 12. Okay, So 2 by 12. When you use the 2 by 12 joist, your span can reach up to the 22 feet when you use the strong wood. It means this one can be 22 feet. Okay, but just kind of one more example, I can just make you better to understand here. But when you want to use the 2 by 10, okay, which is the 2, and here's 10, which is the one joist size. In this case, when you want to use in the normal wood, okay, normal wood can reach up to around 15 feet. Okay, so means between the timber, which is span size, it can reach up to the 15 feet for making the safe structure. It is same as the when you design the loop. It's similar, the span, the scenario. This is span, and then this when you wanna make in the angled ceiling, which is the angled loop, which is gable loop, you can say you need a lifter for the structure. This is we can call it as the lifter, and then from here to here, it is called as the span. So it means depending on the timber product for the lifter, you can just having a different span size. We already understanding about the concept from the previous slide. I just giving the just one example to making the understanding about this concept. So when you want to use a 2 by 8, for example, which is the lifter, which is this is a lifter. Lifter, you can use the 2 by 8. Okay, it means you can reach up to around 15 feet when you're using the normal wood. Okay, so means this span here to here, you can reach up to the 15 feet. But if you're having the larger, the lifter, which is the lifter is here, you can making on the longer span here to here. So means you can just more having the more gentle slope comparing to the smaller the lifter, the timber product. Okay. So also understanding about how you can connect the timber structure to the timber structure. We usually using this hanger. This kind of you can see the hanger. This hanger simply connect to the beam, and then when you're having the joist here, you can just kind of using this hanger to connect to this joist. It is also works in the metal structure or any types of the concrete structure as well. So you can see this is a major beam, and this joist here. You can use the metal hanger to support this joist from this main beam structure. Okay. So nowadays, the timber structure exposed to the outside. In this case, you don't want to expose to these types about the metal, the hanger, because it's not look great. So that's why nowadays we using this dovetail connection. This totally recessed from this timber product. This is all prefabricated. This is a male and female the dovetail. Everything is from the factory fabrication, and then on the construction site, it is simply assemble together in the field. Okay, I think it's better to understanding through this picture, this video, to know about how this dovetail works in the fabrication and construction. You see the actual timber is pre-manufacturing this dovetail. Then you can simply connect this dovetail on the construction site, and then this prefabricating dovetail simply assemble together in a field. Okay. So also this is a pretty old-fashioned connection between the column and the beam. You can just consider using this T plate or L plate to connect each pieces together. But also you can consider about connecting between the different timber product. You might consider using the mortise and tenon, which is it is the traditional method to connect the wood to wood. It requires lots of craftsmanship to tie together. So it means it usually don't have any the glue. It just only having the some joint connection. Okay, you can see this is a joint connection and joint connection using this timber to connect very tightly. It is very highly required craftsmanship to making of this structure. However, this is stronger sometimes and making it more durable. Also, it can make the last of a beautiful structure. You can better to understanding how you can use these types of the joint system to making out this exposed ceiling. It is making out a very beautiful exposed the timber structure. It is giving the unique atmosphere and the unique aesthetic of the space. It is designed by FT Architect. It is archery and the boxing club in Japan. The loop structure is used as the traditional Japanese timber joint connection. It doesn't have any glue, so they just kind of using this exposed structure as the aesthetic manner. So how are they making out this whole ceiling system? They just making the one single module. You see this module here. This is everything, the mortise and tenon, but they using these screw together. Okay, just adding the screw together to from the mortise and tenon idea. So they just making the one single the module and simply proliferating to connecting together to making out the ceiling design. So this is all about today's lecture. So we talk about the basic understanding about the timber product and then the framing idea. So it is also our last lecture, and then we have the module quiz on this Thursday. You can find out the more detailed information from the canvas. Okay, please read through. If you have any question, please send an email. I also upload the study guide. You can just kind of following the study guide. You will getting the good grade for the exam. Okay. Also, I just want to say thank you for the last 4.5 weeks. I understanding about that this is a very difficult situation for everyone. I love to see usually face-to-face lecture, but it is also very difficult time if we meet the face-to-face in a big lecture room. So that's why I just changed to this online based lecture. However, if you are getting the better for the next semester, I love to see everyone in the lecture room, the face-to-face. Okay, but thank you so much for your patience. And then we also tried our best to making out these lectures better. But I'm also always open to talk everyone. If you guys any question related to the studio about this technological question, please email me. I love to see you everyone, the face-to-face, or you can meet in the Zoom. Okay, please let me know. But thanks again all about your participation, and thanks again for understanding about the whole situation. Okay, so good luck for the rest of the semester. Okay, thank you guys, and then see you very soon around. Bye.